All right, so this is gonna be, I think we'll do train body next. And I'm gonna have to repeat this like 1,000 times just to save you some effort. And that is the making sure that all of your parts are in the same file, not just the same folder, but you need to have all of your different part files in here so that you can, it makes it a lot easier to do the assembly if they're all on the same file, the same document, rather than trying to import them. There's a lot of like version issues with that sort of thing. Okay, so let's go ahead and make a new part studio. And we are going to name this, where are we, part studio 1. Let's do right click and rename. Let's call this body. I think it is, what do they call it here? They call it train body or body? Yeah, train body. Why not just call it train body? Even though contextually we do know it is the body of a train, but there we go, train body. All right, so yeah, let's do full screen and let's take a look. So there is a lot, obviously, there's a lot of dimensions on here, and we are going to use all of them. I'm not sure about whether Onshape has the type of offset plane needed to do this circle here, because this circle is going to require drawing a circle on a curved surface, which is not possible. But we need to make a sketch that is like directly touching this top, which means we would somehow need to make like a flat sketch plane that touches this like exactly. And there's a couple of ways that we can try to sort of trick it, kind of like making this hole from the bottom, because the bottom of the whole thing is flat and that's easy to sketch on. But either way, let's just start with some basics and break this up into 3 main areas and then cut away all the fiddly bits. Okay, so the bottom here is like a brick that's this big, extruded this far. And then there's this circle. Well, technically it's an arc. When it's done, we're going to use the circle tool because the circle tool is a lot more forgiving. And that extrudes this far. And then there is this cab part for which you need the dimensions that are on the next page. Okay, you can't make the cab part without this dimension. That is the height of this curve part. All right, so let's settle in and figure this out. Okay, the first brick part, and this kind of gets tricky when there are, like I said, so many dimensions on it. If you follow this extension line down, you can see that at its widest point, it's 2 inches wide. Okay, and then if you follow this edge over, and even though these arrows are outside of the extension line, you can see that it's 0.875 tall. So we're going to make a rectangle 0.875 by 2 and then extrude it 5.5. 5.5. Okay, so let's go like this. And let's make a sketch. And I guess if we're making the 2 inch by 7/8, which is 0.875 of 7/8, let's draw on the front. Let's turn off our origin planes. Let's make a regular rectangle. Might as well start it from 0, 0. Okay, so because this is, and if you've already made the train body, you don't need to remake it. It just we'll do it this way because it's easier later on in the assembly. For this first rectangle, let's use a center point rectangle, and that will make everything centered on our origin planes, which may make it easier for the assembly. Maybe not, but won't make it worse. So we're gonna use a center point rectangle, and you can see that the two clicks are where the center of the rectangle is, and then the corner, as opposed to the corner rectangle, which is like that. So let's go ahead and just make a rectangle of this size. Let's look at it straight on. And like I said, the dimensions are 0.875 this way and 2 this way. Okay, and let's finish sketch and extrude our rectangle, and our distance is 5.5. And it doesn't matter which way forward is at this point, because we're not going to do any constraints that have to do with the center. But if you are all about centering things, you could switch it to symmetric, and then it would do 5.5 total, but half and half. That doesn't really matter. You can do it either direction at this point. I guess I kind of like back. It doesn't matter. Okay. So now we have a brick that is 0.875 by 2 by 5.5, and we can turn off this origin plate or origin point. Okay, next step is let's make the circle on the front, or the boiler part, which for any circle or really any feature, it's about size and location. Okay, the size of this arc is radius 0.75. That's the distance from this center point to every point, every part of this arc. The thing is, we're going to use the circle tool to make it. So that means we need to double it, because when we dimension the circle, the dimension that the number we put in will be its diameter. So in order for this to end up at 0.75, we need to make it 1.5. And its location, the center point here, is 1.375 off the ground. And it is, if we follow this down, 1 inch from the side, which, if you recall, the width is 2. So it's centered left to right, 1.375 off the ground. And we're going to make a circle that's 1.5 in diameter. And then we're just going to extrude it all the way back. Even though I suppose technically it only goes to the beginning of the cab here, it since we're doing it first, we're just going to make the cab on top of it. So we just need to make sure it goes all far enough back. So let's go. Let's make a new sketch on the front here. Look at it straight on. And we need a circle. Let's go ahead and just make a circle out in space. And we're going to dimension the distance from the center point of the circle to the base. That was 1.375. And the center point of the circle to either side is going to be 1. Okay, so we have its location. Then we just need its size. So we're going to click on, still with the dimension tool, go out to the side, and the diameter is 1.5, which will give us our radius. And the dimensioning was a radius because when it's done, it's not a complete circle. It's just using the circle tool and using the rectangle tool, as opposed to using arcs and lines. Circles and rectangles are always closed loops. The program will always let you extrude them. They won't break as easily. They're a little more consistent and predictable. Okay, so we have our circle. Let's finish sketch, extrude, choose the part that we want to extrude, which it knows is that. We do want to switch direction, and so that it's going the correct direction. And this is an important reason why you look at it from a corner when you're extruding, because I'm switching direction, but you can't tell by looking at it if you're looking at it straight on. And that's why, like I said, you look at it from a corner when you're doing any part feature. And the distance, as long as it's far enough back to be covered up when we do the cab, it's fine. But at this point, you might as well just make it the entire length of the train. I don't know what you want to call it, but 5.5 works well here. Okay, so next major feature is going to be the cab, I guess you would call it. And based on what we see here, we don't know how tall the cab is. We do know that it is 1.75 from the back, but we don't know anything about how high or how big that arc is yet. We need to look at it here. Okay, and we can see that the roof here is a radius arc of, the radius is 2.35 measured from this point here. And this point here is also the location of the hole for the hitch peg. So we are actually going to make the hole for the hitch peg first. And then using that center point, we'll be able to make an arc and draw vertical lines and extrude it our 1.75. So like I said, let's make this hole in the back first. And what do we know about this hole? Well, we have a center point here. The center point is 1 inch from the side, which again, if the whole thing is 2 inches, it just means it's centered. Easy. And it's 0.375 up off the ground, just same as 3/8. That's fine. And that just gets you to the center point. That's our location. And the size of the circle is 0.25 diameter. It's a circle, so they give us diameter as a dimension. And this just means how deep that extrusion is, and that extrusion is 0.5. The hole is 0.5 deep. So let's do that. I think we can remember all of those parts. At this point, the front and the back, there isn't really a front and the back, but I don't know if you're going to draw on either the front or the back. Let's just draw on the back. If you didn't, that's fine. There isn't. This is essentially in outer space. There's no up. It just is what you call it. I wonder if you can even, sometimes you can rename the sides, but again, it doesn't matter. But I'm just going to sketch on the back just because that's the way I think about things. And we will start by making a circle of about the right size. And I guess we can go ahead and make it the correct size, which was 0.25 diameter. But it's still blue because we need to dimension its location. And the distance from the center point to the bottom was 0.375. And the distance from the center point to the side of everything was 1. There's our fully constrained circle. Finish sketch, look at it from a corner, extrude, choose just that circle, and switch it to remove. And our distance we want to move is 0.5. There we go. There is the hitch hole. Now, when we draw that back, or the back of the whole thing, let's put another sketch on the back face. And the shape that we need to make is, the dimension we have is an arc. Let me just draw it real quick. An arc that looks like this. Wow, that's horrible. That looks like that. That's slightly less horrible. And has vertical sides coming up the side. Okay, so we just need to make this arc of however big and then connect it with vertical lines, and then we'll extrude that forward. Okay, and the arc itself is a radius of 2.35, and that's the distance from the center of this hitch hole, which we are going to need to use. Okay, so first thing, we have our active sketch going. Let's use this circle Now we have a center point to use. And we need an arc. We need a center point arc, because the parts we don't know where the arc connects to. We know its center point. So center point arc, you can see where the 3 clicks are. First click is going to be the center of the hitch hole, which is also the center of the arc. Second click is going to be above everything and to the left of everything. It doesn't need to line up exactly, just so long as it's farther out than the left side of everything. And third click is going to be somewhere over to the right of everything. And we'll trim that up in a second. Let's go ahead and dimension this to what we want, which is 2.35? I've already spaced. Yeah, 2.35. And then, so this is the right size. We just need a line tool that goes from the corner of our base. Make sure it snaps to vertical, and you should get a click there, and connects to that arc we just made. So it needs to click to vertical like that, and then clicks to the edge like that. And we can right click, escape line, and do another one over here, snap to vertical, and go straight up, and right click, escape line. And we will finish sketch. And now we have this fully full closed loop. We can extrude, choose this, and we don't want it to go that direction. We want it to go that direction. And the distance from before is 1.75. And hit OK. Okay, look, that's pretty darn close. Okay, this is where we got that 1.75 was the distance to here. Okay, so remaining part features, the side for the axles, which is ×4, meaning all 4 corners for 4 wheels. The holes in the front for the, just so. Okay, so you good? Okay, just checking, make sure you're good. Okay. Other part features, we have the holes for the axle. We have the holes for the cow catcher that go in the front, these 3 tiny holes. There is the hole for the smokestack on the top. And then there is just this hole for the engineer to look out, I guess, whatever. Okay, let's do this one first. So looking at the dimensions they actually give us, those are the dimensions we need. That's why they gave them to us. Okay, so we see radius 0.5. That is the radius of this arc. And then we have a center point here, which is the center point of that arc. And that center point is 0.25 from the back and 1.75 from the ground. And it's very easy to make an arc where the center point is on sort of the back of everything, but that would be wrong. The center point for this arc is 1/4 inch from the back. So what we're going to do, and I think this is probably going to be unnecessarily complicated, but we'll figure it out. Let's go ahead and sketch on the side. You can see where we are right now. Let's make our circle. Make sure you don't snap it to the edge, just make it sort of in here. And even though they gave us a radius, we're going to use the circle tool. So that means we need to double the dimension they gave us, and they gave us 0.5. So that means this is a 1-inch circle. Okay. And so that means we just need to dimension its location plus cut off what will end up with those little tails. So let's go ahead and dimension the distance from the center point of this to the back of everything. And that was 1/4 inch, 0.25. And the distance from the center point of this to the base of everything was 1.75. Okay, and if we just extruded this, if we did finish sketch, extrude, and chose this part, and switch it to remove and through all, it would look like this, which is close, but that is not what's here. What's here is flat at the part, or at that portion. So before you extrude, or before you finish sketch, we need to somehow cut lines across there. And I think the easiest way is another center point rectangle that starts from the center of this. Oh no, it wouldn't be center point rectangle. It would be corner rectangle. And so from here, we want it to make sure it lines up with the top and goes at least to the back. Can we get a... it's not giving me snaps to there. So let's just make sure it cuts everything past the back of everything, and we can just dimension this, the height of this, to 0.5, and then we'll be sure it lines up there. And the same thing down here. Let's get another rectangle from here, and as long as the height, I'm going to get some, move these dimensions around so you know what's going on. Okay, as long as the height of these rectangles is 0.5, we know that it will line up with the edge of the circle because it's a 1-inch circle, and it doesn't matter how far back these goes because we're only part we're worried about cutting is that little wedge part. So let's finish sketch. Let's look at it from a corner. Let's extrude. And actually, I think the bottom corners actually work better as far as the lighting, unfortunately. And we want to choose everything we want to cut away, which includes these tiny bits right here. And we'll switch it to remove and change the line to through all. And hit OK. All right, so there's that. Let's just work around the other 3 portions, leaving the last part for the last. Okay, so let's do those, the tiny holes in the front for the cow catcher. And there are 3 holes. 1, 2, 3. That's why it says times 3. And they are each 0.125 in diameter and 0.125 deep. Okay, and you can see these center points of each circle give the location of the center of the circle. Okay, so this top one is 0.625 off the ground, and both of these bottom ones are 0.125 off the ground if you follow the extension lines. And then the center point of the top one is centered on the whole thing, which makes sense, which is 1 inch from the side. And the center point of the side one is 0.375 from the side. And the center point of this one is 1.625 from the left side, but that's the same as 0.375 from the right, because if you subtract that from 2, it works out. Also, you can generally figure out things like this are going to be symmetrical. So if this one is 0.375 from the left, this one is probably 0.375 from the right. But I'm going to put dimensions on the way they show them just so you can sort of experience that. So I'm going to start with my 3 circles of 0.125 diameter, just in the roughly the right place, and then I'll come back for the other dimensions. So I've got a new sketch going here. I'm going to look at it straight on. There's a lot of complicated dimensions here. And we'll do our first circle. We'll just make 3 circles that are roughly the size and location we want. And let's go ahead and dimension them to 0.125 in diameter. I didn't expect that to happen. 0.125. Okay, so we have three circles of roughly the right size. Let's right click and escape dimension. I don't know if you notice this, but the software I have that makes the circle where I click, it when I right click, it's orange. I don't know if you're gathering that hidden in plain sight bit of information, but there you go. Okay, so for each of these three circles, we need a vertical dimension, its distance from the bottom, and a horizontal dimension. And I'll just tell you what they are. I pointed them out before. Okay, both of the bottom ones, the distance from the center to the bottom of everything are 0.125 from the bottom. Let's go like that. And another dimension from the center to the bottom, 0.125. And this one from the center to the bottom was 0.625. Okay, so those are the heights of the circles. We just need the location side to side, its lateral dimension. And the distance from the center point here to the side of everything was 0.375. And the distance from here to the side of everything was 1, because the whole thing is 2 and it's centered. And the distance from here, the dimension they give, is also to the left side, and that was 0.625. 1.625, which again is the same as 0.375 from the side. And this type of dimensioning is called stack dimensioning, and it's a way to put a lot of dimensions in a small space and still make it readable. Okay, so everything has turned black. It is fully constrained and it's in the right place. Let's finish the sketch. Look at it from a corner. Again, I might switch to bottom corner as my new thing. And let's extrude, and you may need to zoom in to get the three circles we want. And we're going to switch it to remove, and our depth 0.125. And hit OK. And there's that. Okay, so let's do the axle holes, and times 4, meaning all 4 of them. That means we can infer that it's identical on the other side. So we are actually going to make 2 holes on this side and then project the edges, or project those circles to the other side, so we don't have to dimension them again. They'll just pop over. And you can see that both these circles are 1/4 20 UNC, which if you look at the dimensions for the axle peg, it has threads on there that match that description, because that's where the axle pegs would actually get screwed in. But even though everything up here has up till now has been decimal, like you would think this would be 0.25 instead of 1/4. This is a screw thread standard, so that's why they would do that. We are just supposed to know that the diameter of both of these holes is 0.25 inches. Both of them, or all 4 of them, are 0.875 deep, and they are both 0.5 off the ground. And this one is 1 inch from the back, and this one is 4.5 from the back, which is the same as 1 inch from the front, because it's 4.5 versus 5.5. Leaves you an inch in both directions, which this wouldn't necessarily need to be symmetrical because we don't have much going on relative to the center plane. The center plane going that direction. So it's not as obvious that they would be symmetrical that way as compared to these being symmetrical on our center plane. of everything. The lateral, I don't know, transverse, who knows? So let's go ahead and draw our 2 1/4-inch circles. A 1/2 inch from the top, from the bottom of everything, and then 1 inch in from either side. So let's go like this. We need a new sketch on the side. Let's get our circles that are roughly in the correct location. Dimension them. Diameter 0.25, like it says. Okay, and the distance from the center point of the circle to the bottom of everything was 0.5. Same thing here. 0.5. And the distance from here to the back of everything was 1. Same thing from here to the front of everything. 1. Finish sketch, and we have our circles in the correct location. Let's extrude. Choose one of the circles, choose the other circle. Switch it to remove, and our distance to remove is 0.875. Check mark. Okay, and we need to project these over to the other side. So first we need to do a sketch on this side. And instead of drawing them, we can go back to the first side and get the use tool, use project tool, and we can project this circle and this circle. And it should be, nope, it didn't work. Let's project this edge. Okay, still with the use tool. Zoom in. Oh yeah, you can see it pop up over there. Okay, you see how that circle pops up? If you click on the edge of the circle, you can see how it projects through. And finish sketch, extrude, and we can choose this circle, that circle, switch it to remove, and distance 0.875, and check mark. All right, so there's that. Normally, the next thing we would do is, do we have tangent to a surface? Projected curve, new plane. All right, so Onshape doesn't have the type of surface or new plane that we need in order to draw on the top here. What we're going to need to do is do an offset plane. We want a plane that touches the surface here at exactly that top, so that we can draw a sketch that is horizontal, and that will give us something to draw the circle on and cut through. So what we're going to do is do a new work plane, and new plane, and then we're going to click on the bottom, and the location we want the plane, we want it to be the other direction. So let's have it go up. But like I said, we want it to be exactly on this top, so we need it to be higher than that. We want it to touch this point exactly. So let's figure out how far away that is from the bottom. Okay, so we need to figure out this point here, because that distance from the bottom edge will be where this plane is. And what do we know? Well, we know that every part of this arc is 0.75 away from this point. And we know this point is 1.375 off the ground. So we know this point is 0.75 plus 1.375. So we'll have that be the offset, which we can just type in because I'm too tired to do it in my head. 1.375 plus 0.75, which happens to be, I don't know, 2.125 maybe, who knows? But we can look at it and you can see this plane right here touches our arc at exactly 1 point. Okay, so this is plane 1. Now we can sketch on plane 1. Okay, and now you can see we have a sketch plane that is on that same surface directly above. We could turn off the visibility of plane 1. And this is where we need to draw the circle in the correct location that will allow us to cut down through this curved surface. And the circle is 0.5 diameter. You can see what it's pointing to, 0.5 diameter, 0.25 deep, and it is 0.875 back from the front. So let's just go ahead and do that. Look at it straight on. And right now I don't have anything to snap to. Let's project or use this front plane. You can see now we have a line to work with. And let's draw a circle in roughly the correct location. Dimension the diameter of the circle to 0.5. And its distance from the center point to the front of everything is 0.875. And we don't have a width dimension, but we know that it's centered. We can just infer that. So from the center of the circle to the side of everything should be 1. Okay, so there we're good. And we finish sketch, and let's extrude, choose that circle. And we want to remove, but we don't want to remove in space. It won't let us do that, actually. It'll probably give us an error, but we want to switch direction. Okay, so we want it to be on remove, and we want to make sure that it's going downward. Because when you switch to remove, it switches direction. The problem is the way we made the plane, it had normal as down. So that's why when we got here, it thought that we wanted to create material down, but we don't want to create material. We want to remove material. So it guesses by switching the direction, but we don't want it to remove up. We want it to remove down. And the depth from before is 0.25. And hit OK. And I think that's it. Okay, so let's take a look at what we have. It does autosave. So at this point, you should have linkage peg, hitch peg, axle peg, hitch magnet, and train body. Okay, and yeah, that's it for this video.